100 meters per second is the initial speed.
Is the initial acceleration vertical negative 9.8? Or not negative, just acceleration? Meters per second squared.
It is vertical.
Yeah, but it's negative 9.8 meters per second squared.
What are you assuming?
Gravity. Or it's on Earth.
Yes, you're assuming it's on Earth. Do we want to keep it on Earth, or do we want to throw it on some other planet?
Probably better on Earth.
Is it indeed? Okay. You don't like it being on Earth? Blame Ethan. Or all those teachers before you that just assumed that you were on the planet Earth. All right, we can fill in one more space before we actually have to do anything, do any math.
Horizontal acceleration is 0.
Give me the whole thing.
Meters per second squared.
All right. Now we have to do some math. Sort of going along with Mark was suggesting. The initial velocity. That 100 meters per second, please don't put that either here or here. That 100 meters per second is not horizontal, it's not vertical. It's got some of both. This is where the trick kicks in. I'm breaking 100 up into horizontal and vertical. And I'm breaking it into horizontal and vertical because our coordinate system is horizontal and vertical. And that's horizontal and vertical because my acceleration is vertical. This is 37 degrees. Now 37 degrees and 53 degrees come in a whole lot. What's so special about a 37 degree right triangle with a 37 degree acute angle? And you'll notice on some of them I'll do 36.8 and there's a whole string of numbers there. But what's special about the 37, 53, 90 triangle? All right, then let's do it the old-fashioned way. Okay. I've got a right triangle. Then my opposite side is my hypotenuse times the sine of 37 degrees. And this will be my hypotenuse times the cosine of 37 degrees. If someone would be kind enough.
The vertical is going to be 60 point, do you want me to go to 3 decimal spaces or?
Sure.
I'll say 182.
60.182?
Yeah,
Okay.
meters per second. And then,
So horizontal is 79.864.
If you round those off and it becomes 60 and 80, what's special about that triangle?
it's 3, 4, 5.
Yeah. The 37 and 53 degree angles show up a lot because 3, 4, 5 triangles.
What's significant about 3, 4, 5 triangles?
If I recognize this as a 3, 4, 5 triangle, that's the ratio there of the sides. If that's the 37 degree angle, then the ratio is going to be 3 to 4 to 5. 3 squared plus 4 squared is 5 squared. And so if that's 100, so multiply by 20, that would be 6, that goes to 100, that's 60, that's 80. It saves a little bit of math. It also, if your calculator is in radians and you don't recognize it, it's a quick check. Oh yeah, if you're doing the hypotenuse times the cosine of this angle under 90 degrees and sine of the angle under 90 degrees, and you get a negative number, most likely, assuming you didn't mistype, the calculator's in radians, not degrees. So we now have these, we have this is, I'm just gonna make it 80 meters per second, and then this is 60 meters per second.
On a test, would you still take those as answers if we rounded it to 80
Yeah.
and 60? Okay.
Yeah, I'm much pickier on labs than I am on tests in terms of rounding.
You find the time?
Yeah. On the comment on there's a test I gave a number of years ago, the 151 test, where I gave the angle as 36.8, whatever, so that it actually comes out to 80.000. And I wrote on there cosine of 36.8, yada, 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 is 0.8, and the sine is 0.6. And a student took that really long value that I gave them, rounded it off, and used the calculator so that they did not come out with the nice even integers that I was hoping they would. They didn't take off for it, but it's sort of a nuisance. So if you were into the passive aggressive game, that's the kind of thing you can do. All right, so we need to find time now. What equation am I going to use?
Displacement
Yeah, displacement.
Which displacement one?
equals initial velocity times time plus 1/2 acceleration times squared.
That one shows up yet again. Recognize the part that is establishing time is the vertical piece. We plugged in the horizontal pieces. Well, first off, we know only two things here, so it's not really going to help us a whole lot. But with three, we can, well, we're picking the equation, we're trying to find time. We don't have the final velocity, so we need the equation that doesn't have VF, but does have T. And it's this one, so I get negative 50 equals 60T minus 4.9 T squared. Now what?
It's a quadratic, so you move it all over to one side.
And so we got 4.9 T squared minus 60T minus 50 equals 0. Now what?
Just plug it into the quadratic.
Into the quadratic?
The quadratic formula.
Okay.
Yeah.
Yeah, I just wanted to, it's a nitpicky thing, I knew what you meant.
That's cool.
This is a quadratic equation, we're gonna plug it into the quadratic formula. So 60 plus or minus the square root of 3600 minus 4 times 4.9 times negative 50. Divided by 2 times that, 9.8. Now, if you're a little bit fuzzy on the quadratic formula, it's probably going to be at somewhere near the top of the first page on a test. Or if I don't write it on there, if you didn't need it or made a mistake, and so you can always ask. If you know you don't need it, but just want to mess with other people's heads, you can come up and ask me to write it on the board just to see if anyone goes, wait a second, where did I need to use that? Or they'll look at it and go, that poor child, can't believe they thought they needed it. We get 2 answers. All right, so we're gonna get a positive and negative answer. So in your mind, think through, is the positive answer or the negative answer gonna have the greater absolute value?
positive answer?
I hope so. Let's find out. I assume somebody's about to share.
For the positive answer, I got, this may be wrong, just depending on how I entered it in the calculator, but I got, 467.347.
I think that is safe in saying that is not right.
I got-
473.46 or 4.469.
Yeah, something's not right.
I got 13.03.
That seems more reasonable.
I also got 13.03.
We have, okay, so we got two people with the same thing. Feeling groundswell here. So it would not explain all of it, but don't forget, there's a square root there, and you're dividing by 9.8 after it's all done, said and done. Some people forget to put parentheses around the top part and just divide this part by 9.8. Or put parentheses in the wrong spot, you get this, divide by 9.8, then take the square root. I'm assuming 13.03 seconds is correct. And the negative answer?
It should be negative 0.78.
And so our positive answer is indeed has a larger magnitude. Again, we're looking at solving for a parabola. Where's the parabola hit the horizontal axis? And we're starting out with it shooting up in that direction. So I would expect the negative part to be smaller in magnitude than the positive. Oh, so that gives us anybody get something else that's in the magnitude or in the ballpark of 13.03 seconds? You got something else?
Oh, okay.
You got 13.03 also? Okay. Just flashing back to the classes where I had several people get all the same wrong answer. So, all right, so here we go. I now know the time it's in the air. How do I figure out how far out it goes? Yep. So delta S equals 80 times 13.03 plus 0. I guess at this point, let me write it out. 1/2 times 0 times 13.03 squared. All right. Other than units are missing.
10,424.
I messed up. What'd you get?
Oh, I did type 800, not 80.
Oh,
That's right.
okay. That's how far it plans from the bottom of the cliff. So this is a kilometer away. And what's the final velocity?
Horizontal velocity?
It's 80.
You said for horizontal velocity? I want the total, but okay, for the horizontal?
80
Yep.
meters per second.
All right, so we got that one. That's 80 meters per second. And what about vertically? how would you solve it? What would you plug into?
K formula.
Which one?
Final velocity equals the initial velocity times area times time.
Times what?
Plus acceleration.
Okay. So, actually, I wanna leave that there, so let's just get it, write it over here. So, VF equals VI plus KT, and so that's gonna be equal to 60 plus negative 9.8 times 13.03.
Now, we better get a negative answer, because I know this thing is gonna be landing below where it started. It's better, since it's going down at that angle right there, the vertical component should be negative. If we get a positive answer, then something has gone amiss.
I got negative 67.694 meters per second.
Did I write that correctly?
67,
Six and five right there.
I said 67 for the first two digits.
Oh, 67.
Yep.
Perfect. No one will want to know.
All right, so come over here. Negative 67.694 meters per second. All right, you get to that point, you're feeling good, you move on to the next problem, and then I come along, grade it, and I take points off. Why would I take points off for that?
Because are we looking for the absolute value, so wouldn't it not be negative?
No, I was asking for the final velocity, so if I asked for final speed, then we would need to somehow come up with that.
Because you don't have a horizontal component to the displacement.
Like, say that again?
Because you don't have the horizontal component to the displacement.
Oh,
why you would take the
that was a
point.
separate thing, but, okay, I guess, 1042.4. No, I would still, I assumed that was been answered somewhere.
Okay.
No, not why we take off.
Is it because we didn't like write it out as like a vector?
The question is, what's the final velocity? You have all the parts there, you just need to get that last little bit. Final velocity equals,
Negative 69.694 meters per second. J hat, or space I hat would be first. Plus 80 meters per second I hat.
traditionally, I hat comes first, but it's nothing that says it has to. This is the final velocity in rectangular form. Let's go ahead and put it in polar form, just cause. I still want to keep that. How would you get it into polar form?
Draw a triangle.
Yeah. I know, again, given our convention here, I know it's going to the right and down. To the right 80 and down is 67.694. How would I find my magnitude?
The dagger here.
Yep. So R squared is equal to 80 squared plus 67.694 squared, which is something. 105.7.
One 104.8.
For R. Per second. And, but polar form also, we need to give a direction here. So let's We'll take that angle, and I'll cleverly label it theta. How do I solve for theta?
The SOHCAHTOA,
Yeah, so which,
the
the tangent, the top, or TOA,
oh, the opposite and adjacent, yeah.
is that the, okay. So I know that theta is gonna be the arctan of the opposite over the adjacent, so 67.694 over 80. And so theta, it's gonna be under 45 degrees. More than 37, close to 37, I'm gonna go with somewhere around 40 degrees. What do we get? 39.64 degrees. The real answer is.
So I'd put it in as a fraction, right?
You can. $40.24. All right. So when I write it in polar form, I write my magnitude, so 104.8 meters per second, and then what is the angle I write down?
40.24.
Unless I missed something.
Would it be 360 minus 40.24?
That works. Or negative 40.24. I would personally go with the negative just because it's one less step to do.